Rolle's theorem, which says that suppose that f is Rolle's theorem says the following. Okay, it says let f be continuous on the interval from a to b, and f prime is defined for all x inside of the interval from a to b. So this is what I mean. If f is the position function, derivative means the velocity. So we are saying the velocity is defined everywhere. And if the value of the function at a is the same as the value of the function at b, then the rate of the instantaneous rate of the function must have been zero somewhere. The instantaneous rate of the function must have been zero somewhere. Am I making sense? And the proof is the same as what we did for the bug, so I'm not going to give you a proof of this again, but that's known as Rolle's theorem. Okay. So Rolle's theorem works for any function as long as the function is differentiable over the interval. You can apply this. Again, what this is saying is if the value of the function at a and b are the same, then the derivative must be zero somewhere. In other words, if you look back to this graph here, what we are saying is that the height of the graph at a and b are the same. Height of the graph at a and b are the same. Then what's the slope of the line segment joining a and b? The points at a and b is zero. So the slope of the line segment joining the points at a and b would be zero because the heights are the same. What we are saying then is that there should be two horizontal tangent lines. So there should be at least one horizontal tangent line at some point C. Am I making sense? So we are saying if the function has the same values at a and b, then there must be a point C where the tangent line is horizontal. Okay, that's what we are saying here. Let's do an example and see what we mean by this. Let's say I have the function f of x, which is x cubed minus x, and let's say we are looking at x between 0 and 2. One of the exercises that you're going to see in your homework is that the following. It's going to ask you to check whether the function satisfies the conditions of the Rolle's theorem. How do I check that? What are the conditions of Rolle's theorem? The conditions are that is the function continuous over the given interval? And is the function differentiable over the given interval? Well, the answer is what? Yes, so is f continuous over the interval from 0 to 2? The answer is yes. And 2, is f differentiable Differentiable means the derivative exists everywhere over this interval from 0 to 2. The answer is yes, because it's a polynomial function. And then the next thing it's going to say is that, well, if it satisfies the conditions, then find the moments in that interval where the derivative would be 0. That is, where the conclusion of the Rolle's theorem will be true. Am I making sense? What's the conclusion of the Rolle's theorem? The conclusion is that the derivative is 0 at some moment, right? So you have to find the moments where the derivative is 0. So find values of c satisfying the conclusion of the Rolle's theorem. So the third thing that you have to do is find values of c satisfying the conclusion of Rolle's theorem. And how would I do that? Well, what is the conclusion of Rolle's theorem? It says that the derivative must be vanishing at some moment c, where c would be between 0 and 2, right? That's the conclusion. And I have to find c. How do I find c? Well, do I know what's the derivative? I know that the derivative is what? 3x squared minus 1. So then I know f prime of c would be 3c squared minus 1. And I want that to be 0. And then that would mean 3c squared is 1. That would mean c squared is what? 1/3. And that would mean c is either 1 over root 3 or negative 1 over root 3. But negative 1 over root 3 is not a possibility because it's not between 0 and 2. So this is the only place in that interval where the derivative is 0. Am I making sense? So you'll be given a function and an interval. You'll be asked to check whether the function satisfies the conditions of the Rolle's theorem, and you're going to check that whether the function is continuous there, whether the derivative exists everywhere. And once you check that, then it's going to ask you find the values of c that satisfies the conclusion of the Rolle's theorem, which means that find the values of c in that interval where the derivative is 0. Am I making sense? Okay, we are not done with this section yet. We'll finish that next time.